Okay, we're here today to do question 1 of ENB 276 structural 1. Basically this is it here with its loads, bending moments, shears and reactions. And what I want to do today is show you how to build this. So here we go. SpaceGass is set up so that everything you need to do is listed one after the other. So it's nice and easy. So first step, we're going to click on nodes. Now from the diagram, node 1 is of course the starting point. Node 2 exists 8 meters to its right. 3, another 10 meters. And the last point is a further 6 meters, so it's 24. Hit OK. Back to structures. Now we need some members in between our 4 nodes. Member 1. Now SpaceGass should automatically fill this in for you. So just watch node A and B. So 1, 2, 3. Yep, and there they all are. So just hit OK and they should be put in. Yep, there they are. So next step, structures, node restraints, because currently our structure is floating in midair. Now from the diagram, node 1 is fixed in all directions, while the other 3 nodes are all roller joints, which is just that diagram there. Okay, so hit OK, structures, section properties. I put this in as 3 sections because these are 3 members. I'm not sure if that's correct, it seems to work. From the assignment brief, we're using universal beams 460 UB 67.1. So we'll just throw in 3 of those. And all I'm doing is clicking on this little notebook over on the right hand side. It contains all of the data we need. Material properties, this is the last one for structures and it's quite important. Hit number 1, and if that doesn't come up, we can just go over to this little booklet. I'm going to click on steel. Now, we don't want steel's self-weight acting on our structure, so we're going to change its density to that. Okay, that's it for structures. If we click on this button here, we can see we've got our load restraints. Now, we don't have any nodal loads, and we're not looking at displacement just yet. So what we're going to be doing is we're going to put on our point load, which is member concentrated. It's acting on member 1. It's also acting in the middle of the member, so that's 50% distance. It's acting in the y direction, and it's going down, so we can call that negative 100 kilonewtons. We're just going to call this loads for case 1. Now what we're going to do also is we're going to put at member distributed forces, which are UDLs. We're also going to call that case 1, so we can keep all our loads under one case. So we have a UDL acting on member 2, starting at 0 and finishing at 100%, so it's acting on the entire member. And because it's uniform, it won't be changing. So its start will be negative 30 kilonewtons per meter, and so will its finishing force. Okay, so case 1, member 3, exactly the same thing. Negative 30. Cool. Hit OK. So now SpaceGass has depicted all of our loads acting on the structure. There's not really anything else we need to put in here yet. So on analysis, click linear, static, hit OK twice, Now on the left hand side we have all these options available to us. So let's get rid of load diagrams and go down one to click on bending, and this is the bending moment diagram for this structure. It will be different to unstealthy's because unstealthy included the 10mm deflection or settlement acting on load 3, whereas I haven't done that yet. We can do that later. So yeah, underneath that again, to the right of it is your shear force, and bottom left is our reactions. So we have a moment going the anti-clockwise direction on point 1, and because it's a roller joint on all the other ones, there are no moments generated. Also see how SpaceGass keeps ghost images up? We can get rid of those. If you just double click on view members, it'll just clean it all up for you. Okay, so that's that. Now we can put in our displacement of 10mm. So prescribe displacements under loads. We're going to call this case 2. If we call it a different case, we can actually get rid of it if we don't want to use it in our analysis. So case 2, node 3, in the y direction, and it's going down because it's a settlement, 10mm. Just hit OK. With SpaceGass, every time you make a change, you will need to conduct a new linear analysis. So just do that. This is it. This is, well, it's doing all load cases. And yeah, there you go. That's question 1.